Today we're going to be simplifying radical expressions. Okay, so when we're talking about radical expressions, what I basically mean is we're talking about square roots and cube roots. So let's talk about square roots first. That would be a good place to start. Okay, so when we're talking about square roots, we're basically talking about this. You're going to have a radical symbol, you're going to have something on the inside, and whatever's on the inside, that's going to be called the radicand. The radicand. It's basically whatever's on the inside of the square root. But we're also going to have another component to it. We have this thing right here. It kind of looks like a long division sign, but this is actually called a radical sign. A radical sign. And usually we have an index up here, but since this is a square root, the index is considered to be 2. So the index is considered to be 2. We just don't write it. Okay, so that's square roots. Maybe I should underline this and put a star beside it. But yeah, that's basically what a square root is. It's a radical sign, and you have something on the inside that's called the radicand. Okay? Let's move on from that, and let's talk about cube roots, shall we? Okay, cube roots. So for cube roots, we're basically going to have the same setup. You're going to have a radical symbol like this. You're going to have a 3 up top since it's a cube root, and you're going to have something on the inside. Now, like I just told you, whatever's on the inside, that's called the radicand. So this is still called the radicand. Radicand is basically whatever's on the inside of the square root symbol or the cube root symbol, whichever one we're talking about. Of course, this is the radical sign, right? This is called the radical sign. And then we have this little number up here called the index. This is called the index. And the index is going to tell you what kind of root you're taking. So whether you're taking a square root or you're taking a cube root or maybe you're taking a 4th root, basically the number is going to tell you which root you're taking. And then finally, let's talk about the nth root. This one is basically just a general kind of thing. So just like before, you're going to have something on the inside. Let's just call it X. You're going to have your radical symbol. And of course, up top, you're going to have your index. This is called the radicand, as usual. This is called the radical sign. And this would be the index. Okay, so that's basically what an nth root is. N can be any number, either 1 or bigger. And this is just a generalized form of a square root. So today we're going to be talking about square roots, we're going to be talking about cube roots, and we're also going to be talking about nth roots. Okay, so let's get to it. Now, the first thing I wanted to do was I wanted to look at the problem sets that we have for today. So let's look at the problem sets. And then maybe if we have some time afterwards, we'll talk about some of your classwork problems that are due on Sunday. Okay? All right, let's do number 1 together. Number 1 says, find the square root of 16. Well, 16 is a perfect square, as you know, and the square root of 16 is 4, so all you have to write is 4. That's it. So that's how you do that. That's a perfect square. All right. Okay. Let me write down the next one. Square root of 50.
I can't hear you. I can't hear you.
All right. Now for the square root of 50, what you're going to have to do is you're going to have to break it up into numbers first. When we're doing square root of 50, notice that it's not a perfect square. Not a perfect square. So since this is not a perfect square, what you have to do is you have to break it up into factors. Now, I know that 50 is the same thing as 2 times 25. 2 times 25. Then I just look right here and I say, okay, which one is the perfect square? It's the 25, right? So what I do is I underline the 25 and then I take the square root of that. So what's the square root of 25? Wouldn't that just be 5? What I do is I take the 25 out as a 5. And I'm going to leave the 2 in there and I'm done. So that's how you do something that's not a perfect square. You're actually going to break it up into perfect squares, and then you're going to take the square roots of that. Okay? Let's move on to something that is very similar. Let's talk about number 3. All right, number 3 is square root of 81. 81 is actually a perfect square. We can take the square root of that. And as you know, the square root of 81 is 9, right? That's pretty simple. Okay, moving on. Let's talk about number 4. 4 says square root of 45. Let's talk about that. Okay, now since 45 is not a perfect square, and I'm just going to make a note of that. This is not a perfect square, as you probably know. 49 is a perfect square, but 45 is not. We're actually going to have to break 45 up. So what I do is I break 45 up into something times something. It's always got to be a number times another number. And one of those numbers has to be a perfect square, right? So what I'm going to do is I'm going to break up 45 into 9 times 5. So let's do that. 9 times 5. So I know that 45 is the same thing as 9 times 5, right? And now I just got to think to myself, okay, which one is the perfect square, 9 or 5? 9 is the perfect square, right? So what I'm going to do is I'm going to underline the perfect square. What's the square root of 9? Well, the square root of 9 is 3, right? So I can take the 9 out as a 3, but I have to leave the 5 under the square root, and I'm done. Okay? So that's how you take square roots of numbers that are not perfect squares. And I'm just going to do an extra one so you can get some practice on this. Let's do square root of 8. What's the square root of 8? So 8 is not a perfect square. Not a perfect square, right? But we can divide it by something that is a perfect square, right? So the 8 can be broken up into 4 times 2. I underline the 4 because I know 4 is the perfect square, right? I underline the 4. And then what I'm going to do is I'm going to take the 4 out as a square root. What's the square root of 4? Wouldn't that just be 2? So I can take the 4 out as a 2, but then the other 2 I have to leave under the radical. And I'm done. So that's how you take square roots of non-square numbers. Okay? Let's take a look at number 5. Number 5. And I'm going to be zooming in on this one because it's kind of important. Number 5. Okay. So 5 says square root of 36, x squared, y to the 6. Okay. So the first thing I do is I start off with the numbers first. What's the square root of 36? The square root of 36 would just be 6, right? So I underline my 36. I know that's a perfect square. I can take it out as a 6, right? And now I work on the variables. What we're going to do for these is we're going to divide all exponents by 2. We're going to be dividing all the exponents by 2. So what that means is I take the exponent, I divide it by 2, and whatever the answer is, I bring that outside. So what's 2 divided by 2? Wouldn't that just be 1? So I can take out x1. Now let's move on to the y's. What's 6 divided by 2? 6 divided by 2 would just be 3, right? So I can take out 3 y's. And I'm done. That's it. All you're doing is you're dividing the exponents by 2. Now, I could also write my answer like this, right? I can also write my answer as 6x y cubed. This is also acceptable. And they're actually the same answer. It's just when I have a 1 as an exponent, I usually don't write it. It's kind of understood to be 1 if I just leave an x there, right? So that's what we're doing now. We're dividing all the exponents by 2, okay? Let me zoom out and let's take a look at number 6. Okay, number 6 says square root of 12, and there's a lot to this, so bear with me here. 12, x to the 20th power, y to the 16th power, and z to the 5th. Yes, that is a z, by the way. Okay? So how do we start this off? Well, first of all, we always look at the numbers first. And when I say numbers, I'm talking about the big numbers that are out in front, right? The coefficients. So let's take a look at 12 right here. I know for a fact that 12 is not a perfect square. So there's actually going to be something left inside the radical when we get done with this. But what can I break up 12 into? I can break up 12 into 4 times 3, right? 4 times 3. And I'm going to underline the 4 for reasons I'll tell you later. Okay, so the 4 is a perfect square. You probably realize that. The 3 is not a perfect square. So I'm going to have to leave the 3 under the square root symbol. But the 4 I can actually take out as a what? What's the square root of 4? Wouldn't that just be 2? So I can take the 4 out as a 2, right? So I take the 2 out and I leave the 3 on the inside. Okay? So now the 12 is done with. I move on to my variables, my x, my y, my z, okay? Now let's divide the exponents by 2. I see x to the 20 power. What's 20 divided by 2? Wouldn't that just be 10? So I can take out x to the 10th. Okay? Let's look at the y's next. How many y's can I take out? Well, what's 16 divided by 2? Wouldn't that just be 8? So I can take out 8 y's. Now here's the question. How many z's can I take out? At the most. See how I have 5 z's? Let's talk about that. We're going to take 5 and we're going to divide it by 2. Just like usual, okay? So what's 5 divided by 2? Wouldn't it be 2 remainder 1? Right? So how many z's can I take out? I can take out 2 z's, right? I can take out 2 z's, but how many have to stay left under the root? Only 1. So I'm going to leave 1 z on the inside, and I'm done. There you go. So the answer for this is 2 times x to the 10th power, y to the 8th power, z squared, times the square root of 3 times z. And I know that sounds complicated, but what we're doing is we're taking out as many squares as possible. We're taking out as many squares as possible so that when we get done, what's left on the inside? We don't have any squares left. That's the point. We're trying to take all the squares out. That's the point of this. Okay? Let's look at number 7. Number 7. Hopefully it'll make a little bit more sense once I get to the others. Let's talk about number 7. Okay, so for number 7, I've got -3 times the square root of what? 25 x to the 7th power, y to the 8th power, and z to the 9th power. Okay, so when I do problems like these, I always start with the big numbers first. What's the square root of 25? Now you know this. What's the square root of 25? We don't have to break this up. We don't have to do anything like that. That's right. The square root of 25 is 5. So I'm just going to take the 25 out as a 5 and be done with it. Okay? So I'm still going to have -3 on the outside. I'm going to have a 5 on the outside, and I'm still left with the square root of all those letters, right? I've still got x to the 7th under there. I've still got y to the 8th. We're going to take them out eventually, but we've still got these letters left under there, right? Now, what's -3 times 5? -3 times 5 is -15, right? So I'm just simplifying what's on the outside for now. Everything else is staying the same so far. Okay? So all I've done up to now is just mess with the big numbers. Now let's take the exponents and divide them by 2. Okay? All right. So let's deal with the x's first. Let's look at the x's. How many x's do we have? We have 7 of them, right? If I divide that by 2, how many can I take out? How many times does 2 go into 7 without spilling over? How many times does 2 go into 7? 3 times with 1 left over. So I can take out 3 x's, but I have to leave one of them left under the radical, right? Okay. Let's move on to the y's now. I've got 8 y's. If I divide 8 by 2, what do I get? 8 divided by 2 is what? 4, right? So I can take out 4 y's with no trouble. And then the last thing we have to do is we have to deal with the z's, right? How many z's can I take out? What's 9 divided by 2? 9 divided by 2 is going to be 4 remainder 1. So I can take out 4 z's, but I have to leave 1 under the radical. It only makes sense, right? So I can take out 4 z's, but I have to leave 1 of them left under the radical. And I'm done. That's my answer. There's nothing left that I can take out, right? Okay. Let's get to 8, 9, and 10, and then we'll work on some of the classwork problems together. How about that? Let me do number 8. Okay, 8 is going to be a cube root. You know why it's a cube root? Because of this 3 right here. This index 3. It says, hey, I'm a cube root. I'm not a square root anymore. I'm a cube root. What's the cube root of 216? Well, by memory, that would just be 6, right? You could do that in a calculator. That's pretty simple. But what about the next problem that we're going to do? Let's look at that one. What's the cube root of 32? That's a good question, right? Let's take a look at it. So for number 9, I've got the cube root of 32. Notice that 32 is not a perfect cube. Not a perfect cube. It is absolutely not. But we can break it up into factors, right? What's a perfect cube that'll divide into 32? While you're thinking about that, I'm going to break up 32 into 8 times 4. 8 times 4. Now, which one of these is the perfect cube? 8 or 4? Well, which one is the perfect cube? I start to thinking about it, and I just think, well, 4 is a perfect square, but it's not a perfect cube. 8 is actually the perfect cube. And what's the cube root of 8? 2. So I can take out the 8 as a 2, right? Let's take out the 8 as a 2. And then the 4 has to stay in there because I can't take it out. And that's it. 2 times the cube root of 4. That's my answer. That's all I can do. All right. And the last one is number 10. Let's take a look at that. Cube root of what? 27, x to the 6, y to the 4, z to the 9th. Okay, let's talk about this. What is the cube root of 27? 27 is actually a perfect cube. You can take that out, right? Just like 216 was a perfect cube. We can take out the 27 as a what? What's the cube root of 27? Cube root now. Cube root of 27 is 3. The 27 is going to come out as a 3, right? Doesn't have anything to do with odd or even numbers. We're talking about perfect squares and perfect cubes. What's the cube root of 27? 3. Okay? Now let's deal with the x's, the y's, and the z's. What we're going to be doing here is we're not going to be dividing by 2 anymore. What are we going to be dividing by? We're going to be dividing all the exponents by 3. Why is that? Why are we dividing the exponents by 3? Because it's a cube root, right? We're not doing square roots anymore. We're talking about cube roots. Those are a little bit more complicated, right? We're going to be dividing all the exponents by 3. So what's 6 divided by 3? Wouldn't that just be 2? So how many x's can I take out? 2. Okay. I'm going to skip the y's for now, and I'm going to come back to them. Let's do the z's next. What's 9 divided by 3? Wouldn't that be 3? So I can take out 3 z's, right? Okay, now let's talk about the y's. I have a 4. What's 4 divided by 3? Think about it. But also think about it in terms of remainders, okay? What's 4 divided by 3? Let's talk about it. 4 divided by 3 would be 1 remainder 1. 1 remainder 1. So I can take out one y, only one of them, and then one of the y's has to be left under the radical, right? So I'm going to have a cube root of y right here, and I'm done. So my answer is going to be 3x squared, z cubed, y times the cube root of y, okay? I'll leave that up there for about a minute, and then for the last 5 minutes, we can talk about the classwork that's going to be due on Sunday, okay? So be thinking about dividing in terms of remainders, okay? You probably haven't done that since elementary school, but it's important because all math is patterns, repeated patterns. Remember that. Okay, let's go to the classwork. Okay, classwork. We are going to be talking about a few problems that may help you out. And I'm going to go through them kind of quickly, so try and keep up. Let's do number 1 and number 2 together. Square root of 25. That would just be 5. Duh, we know that. Number 2. Square root of 24. Okay, this is not a perfect square, not at all. So we need to break it up into factors. And hopefully one of those factors is going to be a perfect square. So what are you thinking? 3 times 8? Well, that's not going to work. None of these are going to be perfect squares, right? So we can't use 3 and 8. How about 4 times 6? That might work. 4 times 6. Now, between these two numbers, which one is the perfect square? The perfect square would be 4, right? So I underline the 4. What's the square root of 4? Square root of 4 is 2, right? So I can take the 4 out as a 2, but the 6 has to stay under. The 6 has to stay under, and that's all you can do, okay? I'm going to let you do 3 and 4 by yourself. Let me do number 6. That's a good one to talk about. I'll do 6 and 10. How about that? Number 6 says what? 32 x to the 10th power and y to the 5th power. Okay. Now for this one, we know that 32 is not a perfect square, but we can break it up into 16 times 2, right? Are you following me here? 16 times 2. And then I still have that x to the 10th and y to the 5th. We'll deal with that later. But let's just talk about the numbers for now to try to keep it simple. Between the 16 and the 2, which one is a perfect square? 2 is not a perfect square. We know that. 16 is the perfect square. So I underline that. And I think, okay, what can I take 16 out as? What's the square root of 16? Square root of 16 is 4, right? So I can take this out as 4, but the 2 has to stay under the square root, right? Okay, now let's talk about the variables. Now, when we do square roots, we're going to have an index of 2. That means that I need to divide all the exponents by 2. So what's 10 divided by 2? Wouldn't that be 5? So I can take out x to the 5th, right? No problem. How about the y's? What's 5 divided by 2? Let me do it down here. 5 divided by 2. That is 2, remainder 1. That means I can take out 2 y's like that, but one of the y's needs to be left under the radical. That's what that remainder means. However many remainders you have, that's how many variables have to stay under the square root. So we need to put a y under there. And we're done. Okay, and let's do the hardest problem together so we can just get that out of the way. Let's talk about number 10. Number 10. Scoop my paper down a little. Number 10 says cube root of what? Cube roots are a little bit more complicated. So let's see. 8x cubed, y to the 6th power, and z to the 8th power. Okay. What is the cube root of 8? Well, luckily, 8 is a perfect cube. We know that the cube root of 8 is going to be 2. So I can take this out as a 2. So far, so good. 8 is a perfect cube. I take it out as a 2. And now I divide all the exponents by 3. We're going to divide by 3. So what's 3 divided by 3? Wouldn't that just be 1? So we can take out 1x. Let's move on to the y's now. How many y's can I take out? What's 6 divided by 3? That would just be 2. So I can take out 2 y's. And then how many z's can I take out? That's going to be the trouble. But if you know how to divide using remainders, it shouldn't be so bad. Okay, so think about it. What's 8 divided by 3? How many times can 3 go into 8 without spilling over? 3 can only go into 8 twice without spilling over. But how many are going to be left? 2, right? So my answer is going to be 2 remainder 2. So I can take out 2 z's. I can take out 2 z's, that's fine. But 2 of them have to stay under the radical. So I'm going to have cube root of z squared, and I'm done. Okay?